Today we're starting 1.10, precision and accuracy. What our main objectives for the day are: analyze and comparing measurements for checking for precision and accuracy. Precision is the level of detail in a measurement. It's determined by the smallest unit or fraction of unit that you can reasonably measure. The smaller the unit is, the more accurate the measurement is. Accuracy is the measurement of closeness of a measured value of the actual or true value. We're also be talking about tolerance. You're allowed a certain amount of leeway, the plus and the minus. You could overmeasure, you could undermeasure. So we have two sets here. We're going to choose which one's more precise. If I have 0.8 kilometers or 830.2 meters, which one's the smaller measurement? Meters. Because it's the smallest unit, this one is more precise. The second question, which one's more precise? 2.45 inches or 2.5 inches? They're both inches, right? So it's the same type of measurement. But which one's more accurate? The 0.45 or the 0.5? Why is the 4.5 more accurate? What decimal place do I have there? What place value is that? Hundredths. The 0.5 is only in tenths. You're cutting something with more accuracy. Think of like if you're cutting a board. If we're cutting a board in shop class, to the nearest foot, there's a lot of leeway, right? To the nearest inch, there's leeway. Then you can go half inch and get closer and closer. Then you start getting to eighths of an inch, and it's dead accurate. What about these two? Why not? That first one's I just copied for some reason. That bottom one, which one's more accurate? 100 centimeters or 1 meter? 100 centimeters is more accurate, but what else could you tell me? They're both the same. But the 100 centimeters is more accurate because the unit is smaller. How old are you? 14. Someone just said they're 14 years old. Is that accurate? Are you exactly 14 years old? Exactly. Was today your birthday? Is today your birthday? No. What month is your birthday? April. So how many months from now is that? Let's see. The 10th month, April's the 4th month, so we're 6 months, right? So you're about 14 and a half years old, right? You're 14 and a half years old. That's more accurate. We could take that and take it down to the day even. We could take it down to the minute, to the second, all of that. Which one's more precise? 2 pounds or 17 ounces? Why is 17 ounces more precise? It's a smaller number. Which one's more precise? The 7.85 meters or the 7.8 meters? Because it has the extra number. Actually, that's why. Because it's more accurate, it goes out further. Next one would be thousandths and 10,000. All right, Ida works at a deli. She's testing the scales at the deli to make sure they're accurate. She uses a weight to test that it's exactly 1 pound. The first scale says it is 1.019 pounds. The next one says it's 1.01 pounds. The next one says it's 0.98 pounds. Which one is most precise?
Scale 2. Scale 2.
Scale 1.
Why?
3 numbers.
3 numbers. It's more precise. I'm not talking about accuracy. I'm talking about precise. This one goes out further. so it's more precise. You have to think, if you're having stuff measured at a store and weighed, don't you want it to be exactly correct? If it's off, you pay too much, or if you're at the store, you could pay too less. Now, which one's most accurate? Accuracy, we're going to subtract from each one. We're still doing the exact three same scales. Now, to find accuracy, you just take the absolute value of the difference, because we can't have a negative here. So I'm going to take the 1, and then I'm going to put 0.000 minus 1.019. What's the difference here? Well, it's going to be a negative, but the absolute value gets rid of the negative. It is different by 0.019. If I subtract here, what's the difference? 0.01. The difference here, 0.02. Which one is the most accurate now? Why did I throw zeros on the end here? I put zeros on the end so they're all the same. Which one now is the most accurate? How could I tell that something's accurate? How much error is there if something's perfectly accurate? Zero. If something's perfectly accurate, there's zero error. What happens as you start missing your target? What happens to your error? Starts to get bigger. So to find out which one's the most accurate, I need to find the one that has the number's closer to 0. Which one has the number closer to 0? The second one is closer to 0. That one has the smallest amount of error. What I want you to do for this one is to find out which scale is the most precise and which scale is the most accurate. I'll make this a little bit bigger. Which one is the most precise? Why is C the most precise? It's to the hundredths. It has 2 decimal places. Which one is more accurate? How much is scale A off? 3.3 ounces. How about scale B? 0.2 ounces. How about scale C? 0.07. This one is the most precise and the most accurate. Bright days blinds makes window shades. The width of a 30-inch shade should be in between 0.18 inches of 30 inches. A batch of shades have the widths of has the width shown in the table. Every single desk in this classroom, they look the same, right? But if we sat here and actually measured them, there's that error. One might be a little bit bigger, one might be a little bit smaller. We went over all these types of examples when we were talking about absolute value. I'm looking and I'm seeing what a few of you are doing. You're going and figuring out every single one, right? You don't have to sit here and do every single one of these problems. Here's my error. It's 30 plus or minus 0.18 inches. That means it could be over 0.18 or it could be under 0.18. If I'm under 1.8 or 0.18, what's my number? What's 30 minus 0.18? 29.82. 82. And if I add 0.18, 30.18. What I have here, what I wrote down, is my value has to fall in between 20.82 and 30.18. If it's in between both of those numbers, it passes. If it's outside of it, it fails. Does this one pass? Does this one pass? Does this one pass?
Yes.
Barely. Does this one pass?
Yes.
Barely. Does this one pass? So the only one that failed was B. Is this method a lot faster than sitting here and doing every single one? When you're doing the tolerance, you do the plus and the minus. It was either too short or it was too long. Try this one. Tell me which lacrosse balls were kicked out. So what's my range of error? When I do the minus, it's 5.00. Less than or equal to x, less than or equal to 5.50. Why am I putting 2 decimal places?
Because all the other ones was 2 decimals.
I have 2 decimal places here, so I want to make sure I still have the same exact amount of, what word am I looking for? Not accuracy, precision. So now I'm looking. Is this one good? This one good? This one good? Nope. Too heavy. This one? This one? We good? Now, 12 pounds plus or minus 3%. It seems that percent's always something that gives everyone a hard time. This means you're allowed 3% of error. Now, first thing I can do, I need to find out what 3% is. It's 0.03, but that's not exactly what the error is. How do I find out the error? I take the 12 times 0.03. For percent, you move it over 2 decimal places. What's 12 times 0.03? Let's see, I'm going to get rid of the decimal places. I have 12 times 3. 12 times 3 is 36. I have 2 decimal places, throw them back in. 0.36. So it says 12 plus or minus 0.36. All right, without a calculator, what's 12 minus 0.36? What's $12 minus 36 cents? $11.64. Less than or equal to x, less than or equal to, if I add on 36 cents, I have 12.36. I find that decimals go by a lot easier if you think about them as money. If I just said that 12 minus 0.36, a lot of you go, but if once I start saying money, you start thinking of the actual tangible thing, and it's easier to work with.